got a call from an environmental company. They deal with a lot of not nice substances and try to recycle, refine, clean up, render down. One of their main things is grease traps, rendering down the fat and all that kind of good stuff. So the air is quite heavy with a lot of caustic, interesting things that tend to collect on the air handlers. These units, I believe we've been doing business with them for maybe 10-15 years, and I have probably put in going on 6 systems for them, just because the aluminum in the coils tends to disappear and turn to powder, just due to the atmosphere in general over there. So unfortunately, probably going to be a similar situation. This particular unit's been there long enough that it's about due for that, just due to the environment over there. So we'll swing out and see if we can help them out. Just out of curiosity, we'll hook up and make sure we have some pressure. It did hiss. So we do have some pressure. So let's go inside and check the indoor unit. Alrighty, we are full of water. So we either have a clogged drain or this guy's freezing up, similar to what we were thinking. 2019. So as I was saying, it's probably about time for this guy. But we'll get this water out, get it started up, and see what we can do. Alright, we gave the thermostat a few minutes to time out after we got the water out. These safety switches on the pan and this pump would essentially cut low voltage power in the event that they filled up. So we'll run outside and check the refrigerant now that we've got this cleared up. Alright, we are now operating out here. And we are running low pressure, 16-degree vapor saturation point with 73 psig. It is going up a little bit, but looks like we're probably low. So we'll go check that inside coil real quick. And that's what I was talking about, being a little bit of a caustic environment here. So, as we thought, leaking in here, so we'll see what they want to do. So this thing is leaking, but we're going to try to save as much refrigerant as we can. We can close these service valves and essentially allow the compressor to pull everything back that's in the inside coil and basically valve it off to the outdoor unit, let it hold in the coil and in the accumulator, so that way we try not to waste any refrigerant if we can get away from it. So we'll close this liquid side valve. Partially close the suction. We'll close this completely when we get the system pulled down low enough. Purge these a little bit just to make sure there's no air inside our lines. I'm going to go ahead and open my manifold so that way it can just pull completely through my manifold as well as the indoor coil. And we don't want to pull it into a complete vacuum in this particular case because we do know that that coil on the inside is in fact leaking. We've activated our compressor. You can see the refrigerant pulling down essentially through it as our compressor is pulling all of our refrigerant section in the line set back into itself out here. We'll let this drop fairly low. Again, we don't want to let it get to the negatives. Got to about 4 pounds. I don't want to go any lower than that. Don't know if I've ever pointed this guy out, but it's a low flow regulator for nitrogen. Essentially, any oxygen or air inside these lines, when we heat it up enough to do brazing, can develop a scale. It's like an oxidation. It literally forms almost scale-like material inside the lines, which can clog things up, cause issues. So we attach these low flow regulators and allow a little bit of nitrogen through there, so there's no air inside the lines. And as that happens, it prevents that scale from forming. So we'll hook this up to Jacob and get ready to heat that thing up in there. We'll get it going.
What the heck? Why does that happen? No, instead of having them flat on the front,
yeah,
they're up. So is that a common on the high voltage side of the transformer?
So yeah, basically your high voltage is coming to this transformer. So that's your 240 volt connection, and they're just pulling the common for your fan motor back to this transformer, and then there's our high speed. And if you were to trace them all the way back over, they connect to opposite sides of that contactor.
So M1 and M2 on that board are just dogs?
Yeah, M1 and M2, basically unused motor terminals. So you do have 3 different speeds, medium, low, and high. And we'll just use high since it was already on high.
Okay.
Good.
Yeah, it should be.
Our vacuum held and our pressure test held, so we'll go ahead and open our valves. And according to both our charging chart, showing it's approximately 60, 66, 65 degrees, read across 63 degree into a wet bulb, 23 to 19 degrees. Our charging computer here had it 63.1, 64, so they both fairly well agree, 23 degrees. And we should be good to go. These are compression caps, so get them about finger tight with your hands, and then we'll take our wrench and tighten them the rest of the way. You want to do it with your fingers first so you don't cross thread these brass caps. Well, it looks like we need a little more. Shoot for 23 degrees. Superheat there.
Okay.
I know you can do it.
Yeah.
You tighten those caps.
Ah, the surface caps. Yeah. I thought you were talking about the ones for the ports.
Very, very close. 13 ounces in there. So it's 23 plus or minus 2 according to their charging information. So technically we'll let this settle out a little bit. That's probably going to be it. Alright. That one's always an interesting case. The unit serves the manager's office and the break room and the little hallway separating the two. They do have nice big thick rubber gaskets on the doors. However, the hallway serving the two rooms, the door tends to be left open to the plant quite a lot, and it's just pulling in all that 90% humidity air and whatever chemical happens to be in the air that tends to be real corrosive. I've thought about trying to do some outside air ventilation, but with them leaving the doors open, it doesn't really help. And then on top of that, the only real places, because of the layout of that building, would be that alleyway we were in, or possibly the roof, but all the combustion products from their boilers come out right there on the roof. And then on top of that, the air quality outside of that building is so much worse than even in the office. I don't think it would honestly help. If it were anywhere else, I would assume that level of corrosion on the galvanized housing for the motor would likely be caused by some kind of impingement of airflow, temperature in that unit getting way too cold and condensating air, and likely humidity issues. But we know we have humidity issues, and we know we have interesting products in the air, so realistically there's not too much we can do. On this guy, I was able to get an entire air handler for cheaper than I could actually just get the coil itself. Goodman is trying to get rid of that particular line of equipment as they're moving everything over to R32. So as I said, I was able to get that air handler for, honestly, I think it was around $100 cheaper than I could just get the coil. So we went ahead and replaced the blower housing and blower motor and coil as well. Essentially the whole inside of that unit is a new unit. So we'll get a few more years out of it that way, and leave them cooling for now and move along to the next one.